So I'm broadcasting from my kitchen instead of in front of the classroom, but I'm still going to work through a few problems here for you. So I got a request to do an example off the area of Polygons worksheet. So Max, you want to zoom in here on what we're doing? Just some advice if you're like us and don't have a printer. One thing I did to help me draw them was I just put my paper up against the screen and traced over it. So if you're having trouble kind of sketching out what's there and don't have a printer, that's an option. All right, so do you want to move around so you're like behind me instead of, so basically you just need to get the paper. All right, so we're at take 2 here now. So we're going to go through and go through all the questions that are asked on the worksheet. So first thing they're asking us is to find some angles. So I'm going to start by drawing my triangle. So the first part of that triangle is the radius. So from A to P is the radius. It goes from the center of our shape to a corner, a vertex on the shape. Same thing, same idea as with a circle. The apothem is very similar to an altitude. It goes from the center and drops straight down and makes a right angle. I think on your worksheet it tells you to call that AB. So I'm going to name that point right there B. When we do that, if you watched the video before, it splits these two into two congruent or equal pieces. All right, so I'm going to go through now and answer these questions. So I've got to find some angles. So first thing I'm going to do is break this into big triangles. So if I go from the center and draw out from the center to each corner, I end up with 1, 2, 3, 4, 5 big triangles that are made up from the center and the sides. So all the way around is 360 degrees. So I'm going to take that 360, divide it by 5 because there's 5 of those to figure out what that central angle is. So I worked this out on the calculator already. That comes out to 72 degrees. So the measure of angle PAQ, or any one of those central angles, would be 72 degrees. Okay. However, that's not very useful to us here. We need to make right triangles so that we can use our sine, cosine, tangent relationships. So in order to do that, I have to figure out not only this whole angle, but just what's this piece right here. So then I can start using parts of my triangle to find that. So since this bisects the side, it also bisects that angle. So what I'm going to do is just take this 72 degrees we found. And if you came up with a different number in a different shape, you would just take whatever that number is and divide it in 2 because that bisects that angle. So when I do that, I end up with 36 degrees for the measure of angle PAB. All right. So from there, in order to find the area, which is the goal in these problems, I need the apothem, which is this right here. And I also need the perimeter. So perimeter is kind of more of a multi-step thing. So to go backwards from that, before I can find the perimeter, I need to know what the side length is. And before I know what the side length is, I have to find what half of the side length is. And I can do that using my triangle. So I'm going to go ahead and call that X and call this Y so that I can work with those. So to find X, I need to go back to my given information. So in each one of our problems, there's some information they're going to give us. Here they give us the radius. So we go through and label whatever they give us, and then we can use that to find the other things that we're missing. Sometimes we luck out and they do give us the apothem and the side length. So if they do that, don't overthink it. Just use it. That's the information that goes there. This is actually one of the harder ones. All right, so then I'm going to use our trig function. So our SOHCAHTOA. Been a little while since we've seen it and used it, but it still exists, it's still there, and it can help us find missing sides when we know we have a right triangle. So I am going to use sine here to find, since I have opposite and hypotenuse. So I'm going to use the sine of 36 equals the opposite side, which is x, over the adjacent side, or I'm sorry, over the hypotenuse, which is 10. So here I'm going to put this over 1 and cross multiply, so I get that x equals 10 times the sine of 36. From there, you just need to pick up a calculator or go into Desmos. Just make sure that you check that you're in degree mode. If you're not in degree mode, all of your answers are going to come out wrong, so that's really important there. In this case, when I typed that in, I got that x was about 5.88. So we're going to go ahead and just round to hundredths here. Okay. So from there, I'm going to double that because that was, so this is 5.88, which means this side over here would also be 5.88. And I don't think I calculated this one out, so we'll add those two together. And we end up with 11.76 for our side length, which would be the same here. I just labeled it there so it wasn't quite so crowded. So my side is going to be 11.76 feet. So I'm going to go ahead and fill that in up there as well. All right. Once I have the side length, I can find the perimeter. So to find the perimeter, I've got 5 sides here. So since it's regular, that means that all of my sides are the same. So I'm just taking that 11.6, I'm going to times it by 5 here because we've got 5 sides, and that gives me that my perimeter is 58.8. So I'm going to go ahead and fill that in as well. So the last thing we need to finish this up is to find our apothem, and the reason we need that is because that's used in our area formula. So if you watch the other video, the formula for the area of a polygon is 1/2 the apothem times the perimeter, so we need to find both of those things in order to find our area. So to find the apothem, I'm going to go back to my trig functions, except this time I'm going to use cosine because it's the adjacent side to 36. So I've got the cosine of 36 equals the adjacent side, which is y over the over the hypotenuse, which is 10. So here I'm going to cross multiply these. I get y equals, I forgot my 10 again. 10 times the cosine of 36. And again, we're going to type that into a calculator, making sure everything's in degree mode. And when I do that, I get 8.09 rounded to the nearest hundredth. So my apothem is 8.09 feet. So from there, I'm just going to take all that information and plug it into my area formula. So I've got 1/2 times the apothem, which is 8.09, times my perimeter, which was 58.8. And I'm going to take that all in the calculator. So 0.5 times 8.09 times 58.8 gives me 237.85, and that's going to be in feet squared because when we measure area, we measure it in square units. So there's all my answers for this one. Again, I am having to go through everyone's work here, so the more organized you can keep it really, really helps me here. I got about 120 of you guys, and each of you turning in 10 to 15 assignments, so it's going to be really important that I can just look at it and clearly see your work. I would hate to make you do something you've already done again, but again, I have to be able to follow your work and see what you've done, so make sure you're being aware of that as you're going through. So here's an example of what I would consider to be organized work. I can see all your measurements there that go with it. If you have any questions, make sure you leave me some comments on the question document that's linked in Google Classroom. It's also linked to your HyperDoc, and I will respond there. Thank you. See you guys.